Hi, I'm Monique Henson and I'm a PhD researcher at the University of Manchester. So a star, like our sun, is basically a big ball of hot gas that emits light. The way we think stars form is that if you have a huge lot of gas, gravity will want to pull it together. Gravity is present between anything with mass. That's why the atmosphere is held to the Earth, for example. So you take this big lot of gas, and gravity will pull it together. So it gets denser and denser and denser and smaller and smaller and smaller. When you compress a gas, so when you push it together, it gets hotter. It's getting denser and hotter and hotter and denser. And eventually it will get to the point where it's so hot and so dense, it will produce its own light through nuclear fusion. A galaxy is a collection of hundreds of billions of stars all held together through gravity. So they're normally in like a disc shaped like this, and sometimes they have spirals. Our sun is in a galaxy, and this is a picture of an artist's impression of our galaxy, the Milky Way. It's pretty beautiful actually, these kind of long spiral arms and like full of blue material, and you can see all those bright points in it. Those are all stars, just like our sun. It's an artist's impression because we're in it, so we actually can't see it. The universe is everything that we know of. So not just the solar system that we live in or the galaxy that we live in, but everything else. Because the universe, we think, has lots and lots of galaxies in it. It's everything we can see in the sky. We actually don't even know where it ends because we can't see the end of it. But it is. Dark matter is a type of matter that doesn't interact with light. So everything around us that we can see, whether it's what makes up the table behind me or the wall, interacts with light in some way. So it reflects, absorbs, or transmits light in some way. Dark matter doesn't do that, which is a little bit odd. And that's actually why we can't see it. So the name dark matter is kind of a bad one, because if something is dark or black, then it absorbs light, which means it's interacting with light. And dark matter doesn't do that. So a better name might be invisible matter or transparent matter, but it's not caught on. Actually, there's more dark matter than normal matter in the universe, and we know that it's there because it interacts with things through gravity, and we can see its effect on everything around it. But we still don't know what it is, and we're still figuring that out. So dark energy is this kind of fairly mysterious, I guess, thing that's causing our universe to expand faster than we expected. So our universe is expanding anyway, and it's just been rushing apart since the Big Bang. But that expansion is actually getting faster now, and we don't know why. And this was only discovered in the late 90s, so not actually that long ago, when some astronomers looked out and they saw that some things were further away than they thought they were. And again, no one really knows why. And to be honest, when this came out, it kind of flipped the whole field on its head, because no one had seen it coming. So a black hole, it's a really small, dense object. So small that it's small, much smaller than the Earth, probably even smaller than the end of your pencil. Really, really tiny. But it's got more mass than the sun, so it's massive, and it's so massive that nothing can escape it. Whether it's stars or planets or gas, anything that goes into a black hole doesn't come back out, including light, which is why we call it black. Because it absorbs any light that hits it, which means that it looks black on the sky. And we think that every galaxy out there has a black hole at its centre. And they actually affect the things around them because they gobble up the gas around them because it pulls them in through gravity. But also they can throw out these big jets of matter as well, which affect everything else around it. On really large scales, if we could see everything in the universe, it would look kind of like a web. So you have, like kind of filaments where there's lots of matter, and then you have empty space where there isn't any. And we call this the cosmic web. Now, it kind of seems a little bit odd that the universe would have that structure, but it turns out that because gravity tries to pull things together, that's what forms this web-type structure. So if you've already got some matter together, any other matter that's nearby is going to be pulled towards it through gravity. That just pulls together anything with mass, regardless of what it is. And that's